LeetCode question number 968, binary tree cameras. This is hard question. Let's get into it. Given a binary tree, we install cameras on the nodes of the tree. Each camera at node can monitor its parent, itself, and its immediate children. Calculate the minimum number of cameras needed to monitor all nodes of the tree. Okay, let's take the example 1. Now we are given tree, and then in this case, okay, let's say if the camera is here, and then maybe boundary is here, and they put the camera here, boundary is must here. So the best position of camera is here to cover the all. So the output is 1. And then next, if camera is here, maybe boundary is here, so this is the out of boundary. So if it here is the camera is boundary here, so camera is here, so all of covered, so output is 2. Okay, how we can solve it? Okay, I think that this question is the similar of Columbus the egg. So when you meet the first time, I think everybody head is turn white. So but after you solve this kind of question, next time maybe I think that you easy to solve it. So okay, today I'm gonna use the greedy approach, and then first I will traverse the node, and then I would like to use the bottom up approach, and then I will use the first order, left and right and root. So after I get the left information and right information, I will decide which one is the best decision for the current option. So that is greedy, right? Okay, let's think of it. Okay, first I think there are 3 status of each node. So first is I think the uncovered is, let's say it is 1, and the second is covered. Covered means this is covered, monitoring, but it does not have camera, and then last is has camera, is 2. So first, okay, let's think which one is the best option for first state for this one. If this one has camera, the boundary is only here, right? But okay, let's say if it does not has camera, that is this is uncovered, and then next time we needed to install camera, right? So range of camera is the 3, 1 bigger than has camera. So first we needed to start this one state is uncovered. So and then then let's make recursion first, the traverse, and then receive the current node. And then okay, let's make the base case. If non node, and then which number is returned? 0? No, 0 is not correct, because this state is the not the leaf state. This is the out of boundary over here, right? So that is region node is the none. So in this case, if this one has the 0, it must be 2, because it must be boundary 2. So to make this one is the 0, we needed 2. This one is, yeah, that's right, covered. If this one is covered, and then this one must be not covered, and then next time we needed to put camera here, right? So this one is 1, and then we will do the first order, right, left, right, root, and then root is the decide from the information from left node and the right node. So this is the first order, right? Okay, the left node is traverse, node left, and then right node is traverse, node right, and then okay, let's check if left node is, which one is good? what is the condition for make the new? That time left node is 1, right? And or right node is 1. At this time, currently is that we needed to install, right? So at the time, no, sorry. 1 is 0 is we needed to cover it, right? That means now this one is 0 means that time is we needed to install. Otherwise, if we install it, it is we'll able to change it to covered. Okay, so at this time I will create a counter. That is camera counter. And then I will return. Now we have camera, right? So status 2. Let's see if left node is now left node is 1 and in this case left node is 1, this is covered, and right node is covered. No, that is not. Okay, next is 2. If one of them has the camera, and then that area is, that's right, this is covered. And then else return 0. Otherwise, we return 0. And then next time we needed to cover it, right? Okay. And we needed to check one more thing. If the root is here, and then this one is uncovered, that means we needed to install this camera to cover, right? So I will check if traverse node is 0, not covered, and then we need to add one more camera, right? And then we can count. Fix the typo. Okay. We left that or right node is 2. Or this is or. One of them is the camera, this one is the covered, right? Okay, awesome. Okay, let's check the complexity. We use the recursion, and then time complexity is we touch it every node of tree one by one. So time complexity is linear time, and then space complexity is this recursion use the system stacks. System stack size is same as depth of a tree. Worst case like this, the depth is same as number of nodes. So we can say worst case. Space complexity is linear space, linear time, and linear space. Thank you.